Hello to everyone. Today we are going to discuss about the Wheatstone bridge. It is a very important application of Kirchhoff's first law and second law. For your kind information, I am just giving the thing about the Kirchhoff's first law and second law. Actually, what is the first law? At any junction, the algebraic sum of the current is 0. And the second rule, the product of the current and the resistance in a closed circuit is equal to the EMF of the circuit. Okay. Now we are going to apply these two laws in the Wheatstone bridge. So it is very important from the diagram. If you are able to understand the diagram, then the remaining part is very simple. See, I am just starting from the battery. Look at the battery. This is positive terminal and negative terminal. So here it just have the connection like this. Now it is having the potential V and it provides a current I. Now when it reaches here, I am going to make it into two junction. In these two junction, the current will be changed from I1, I2. That is, the current I will be split and it will make, for my convenience, I am just giving I1, I2. And there it just meet another one junction there. Then here also another one junction. So both will be joining at this point. Okay. See, here the current will be I3 and here the current will be I4. Please look at the direction of the current. So this current will be split and it will be terminate and it will be reaching the negative terminal. So here I told the junction, so here I am just connecting one galvanometer and it will be joining here. Now I am going to name the junction. Okay, that is, this is A and B and C and D. Now the current terminated here. Okay, right. Now I am going to give you at the junction B. Okay, at the junction B. Okay, at the junction B here. Okay, now I am going to apply the Kirchhoff first rule at B and D. Okay, see, simply at B. See, this is the current. This is current IG. Okay, what is Kirchhoff's first rule? The current meeting at any junction is 0, and moreover, the current meeting towards the junction will be taken as positive and moving away from the junction will be considered as negative. If it is so I can write I1 minus IG minus I3 is equal to 0. Because I1 is moving towards and IG and I3 moving away. At B, so at D, okay, here, so this is IG is moving towards, I2 also moving towards, but I4 will be moving away. Okay, so now I just write I2, okay, plus IG minus I4 is equal to 0. So here I am just going to connect some resistance. Okay, so see, so this is, I just make the resistance P, and this is, I just make the resistance Q, and this is, I just make the resistance R, and this is, I just make the resistance S. Okay, so what is its meaning? There are 4 resistors are connected here, P, Q, R, S. Now we are going to find the relation between this B, Q, R, S. Right. Now first I am just connecting, I am just taking the closed loop A, B, D, A. Okay, A, B, D, A. So if I will say the closed loop, definitely I must have used the Kirchhoff's second rule. What is the second rule? The product of current and resistance. So when I am entering the Kirchhoff rule, it is very important to find the direction of the current. See, now I will start from A, B, D, A. Okay, now look at the direction of the current. I1 is moving here, IG is coming down, and I2 will be moving from A to D. Okay, now start from AB. AB, the product of current and resistance is I1P. Then here B2D, the product of current and resistance is IG. Let me take the resistance of the galvanometer will be capital G. So simply I just take IG capital G. Now it is very important. So now when I move from D to A, actual current is moving from A to D. But now I am in my closed circuit, I am moving from D to A. So it has to be considered as minus. So minus I2Q is equal to 0. Okay. Then now, so let me take the whole closed loop, that is A, B, C, D, A. Okay. See, in this, start from AB. Okay, I1P. Then B to C, that is plus I3R. Look at here, I am moving from C to D, but the actual current is moving from D to C. So I have to consider this as negative. So minus I4S. Even here also the same. I am moving from D to A, but the actual current is moving from A to D. So that is minus I2Q is equal to 0. Okay. Now these are all the 4 equations we have got from this circuit, and these 4 equations are very, very important. And now actually what is happening in the Wheatstone bridge now, see, there is a battery. From this battery the potential will be delivered. This potential will be delivered across all the 4 resistors equally, or it depends on the value of the resistance. Because we know that according to Ohm's law, V is equal to IR. Okay, how much the resistance is there, and according to the current and the product of current and resistance, the EMF will be distributed. When the EMF will be distributed equally to all the 4 resistors, or when it is being balanced, okay, so the current flows through the galvanometer will become 0. So when I consider, when IG is equal to 0, IG is equal to 0. Okay, now what happened to this one? So this one will become I1 is equal to I3. First assumption. Second, I2 is equal to I4. Second assumption. And the third, from this, see, I1P is equal to I2Q. Okay, third. Okay. So these 3 has come only when I have considered IG is equal to 0. Okay. Now I am going to apply all these 3, all these 2 in this equation. Okay. So shall I write? See, when I write I1P, okay, instead of I3R, I am going to write again I1. So plus I1R minus I4S. Okay, so here I2 is equal to I4. So simply I just take I2S minus I2Q is equal to 0. Okay. See, what are all the conclusion we have got the Wheatstone bridge so far is, that is I1 is equal to I2 and I2 is equal to I4. Then I1P is equal to I2Q. And the third one we have got I1P plus I1R I1R is equal to I2Q plus I2R. Okay, so let me take I1 as a common term, that is P plus R, and which is equal to I2, this will be S. Okay, Q plus S. Okay, see, in the both side, I'm going to divide. Now consider this is equation number 1 and this is equation number 2. Now I'm dividing the 2 by 1. Okay. So if I divide the 2 by 1, what may happen? Just see. That is I1 into P plus R is equal to I2 into Q plus S divided by here left side I1 of P and which is equal to or I2 of Q. Okay. Now I cancel I1, I2, I2. Okay. The remaining term I have got is P plus R by P is equal to Q plus S by Q. Okay. Or in other words, I can just write 1 plus R by P is equal to 1 plus S by Q. Okay. So now I can cancel 1 on both sides. So R by P is equal to S by Q or P by Q is equal to R by S. Okay. So this is the important condition of the Wheatstone bridge. Actually, what is the important condition of the Wheatstone bridge is, so you see in a Wheatstone bridge what we have got the circuit like this. Okay, so here I have connected one resistance here, here and here. Especially this is P and this is Q and this is R and this is S. Anyhow. Okay, so the ratio between these two will be equal to the ratio between that two. Okay, that is the main condition. So what is the use of Wheatstone bridge? I can measure the unknown resistance which has connected in a given circuit. Okay, thank you.